Hi guys, welcome to Links our YouTube channel. My name is Ram Mishra and I'm your online instructor. So what's new in this video? In this video we will talk about Kubernetes network policies. But before start the lab session we need to understand few points, which is what is Kubernetes network policy and their use cases. So you can see my own browser. This is official documentation of Kubernetes, and as per the documentation, if you want to control traffic flow at the IP address or port level for TCP and UDP protocols, then you might consider using Kubernetes network policies for particular application in your cluster. So Kubernetes network policies lets user define a policy to control network traffic. By applying it, we can allow or restrict the traffic to and from any port, and network policies can be thrown off as the firewall. But remember one thing, if you want to implement the network policy, we need to use a network plugin. See that is clearly mentioned in your, this is the prerequisite that is clearly mentioned in the documentation. Network plugin is very important here. So network policies are implemented by the network plugin, and to use network policy you must be using a networking solution which supports network policy. The network plugins needs to support of network policy to ensure to enforce a network policy definition in Kubernetes cluster. Otherwise any rules that we are apply are useless. So we have some very common and useful network plugins that support network policies are like Calico or Cube Router or Romana or VNet. So we can go with anyone. For more information about network plugins, we can take the reference from here. You can click on network plugins and you can get the information. If we talk about the by default behavior of Kubernetes port, the by default behavior is that all ports are non-isolated and can communicate with each other. However, ports can be isolated by having a network policies in Kubernetes. Network policies can work on all of the ports within a namespace, or we can use selector to apply the rules to port with a specified label. The network policy can be applied to the ignore ingress as well as egress traffic. Ingress means the traffic coming to the pod. Egress means the traffic outgoing traffic from the pod. And policies are applied without the need of restart the running pod. So in this demo, we will see how we can work with the Kubernetes policies. And if you want to just know the code, if you want to get the code is here. You can go with this code, kind network policy, and the entire code is here. So let's begin the lab session. So I'm quickly move to my demo machine. Here it is, and currently I'm using one single Linux machine, and I have already installed Minikube Kubernetes cluster. So let me show you the OS release version first. This is RHEL 9.3, and if I check Minikube status, uh, yeah, it is in running condition, right? So before we moving to next, we need to verify the status of cluster. To check the node availability in the cluster, we need to run the command kubectl get nodes. So okay, it is one node. Minikube is ready for us. See, my Minikube single node cluster is in ready condition, and once our node are available in the cluster, we are ready to create our first pod. One more thing here which is very important, we need to check which is Calico network plugin is running or not. To just verify the Calico is enabled and it is running condition, we need to looking for Calico pods in kube system namespace by using the following command. So we can go with this command kubectl get pods -l ksf Calico network Calico node in kube system namespace. So if I press enter, yeah, here you can see I have a Minikube cluster running with Calico plugin. So now move to the first step, which is checking default allow all rule. As I talked earlier, any pod can take to any other pod by default. Anyone can talk anyone, right? Let's verify this behavior. So here I'm going to create three pods, one for front-end application, second for back-end application, and third for database application. And by default, they should have abilities um, to communicate with each other. So to achieve this goal, what I will do, I will create service file and pod file. So let me go with the pod file first, pod.yaml. So let me go in my notepad, and here I have write down the pod.yaml file. So let me copy the code and then I will explain. So okay, yeah, here it is. Let me save it first. So now let me explain this entry. Here the kind is pod. Here you can say this is the pod, right? And this is my first this is my first port named front end. The first port is front end. I told you we'll create three pod. So this is the first port named front end with the front end label is attached, and in the container section we are using nginx container image, to launch nginx container on port 80 based on TCP protocol, right? In the same manner here the second port will be started. Let me go on line number 16 to line number 29. So in the same manner we have the second port named backend with the backend label, and in the container section we are using the same nginx container image to launch one more nginx container on port 80 based on TCP protocol, right? Now we talk about the third one. So line number 30 to till at the end, this is the third port. Here we have the third port name MySQL with MySQL label, and in the container section we are using MySQL container image, this one which is the latest one, right? To launch one MySQL container on port 3306. So if I scroll down here, the port is 3306 on based on TCP protocol. And here I need to configure some environment variable, which is like MySQL underscore user, MySQL underscore password underscore database, MySQL underscore root underscore password, right? To work properly, we need to configure this one. We have to assign the value. So here I have assigned the variable and the value. So MySQL underscore user value is MySQL, the password is MySQL at date 123, database is DemoDB, and the password, whatever you can set it, right? So these entry can be changed according to your scenario. So here I have defined the variable with the corresponding value, and now let's launch the service.yaml file, right? So I have saved and quit. Now let's talk about service.yaml. So service.yaml, let me copy the code again from my notepad one more time. Okay, now let me explain. So here I'm going to launch three service YAML file, three services you can say, and which is pointing to the all three ports. So here I'm going to configure front end service for front end port, backend service for backend port, and DB service for MySQL port. So let me explain one more time here. The kind, look at the kind first. The kind is service. My first service is front end service, right? Which targets to the front end port. Here's the port which I'm going to target it, and using the selector section here I'm going to go with the front end port, and the target port is 80, right? So in short, this is a service designed for front end port, and if someone hit for target port 80, we will get the response from container port 80, right? So 1 to line number 14, this is the first service which is known as front end service. Now on similarly way, from 16 number line to 29, the second service, the service name is backend this time, and having the label backend, which target to the backend port using selector section, and here the target port is also 80, right? And the third service is line number 3 to 42. So the third service is DB service having the label of MySQL. This is the label of the MySQL is label, which target to the MySQL port, and using selector section the target port is 3306. So this is DB service point out to the MySQL. So just keep it in mind, all of these port have unique label assigned, right? So front end to point out to the front end, backend point out to the backend, and DB point out to the MySQL port, right? Now my service file and my pod file are ready to deploy. Let's deploy it using kubectl command line tool. So I will go with kubectl apply -f, say service.yaml and pod.yaml both. See, services front end created, backend created, DB created, front end, backend, and MySQL pod is also created. So you can see three pods and three services are available in my Kubernetes cluster. So let's check the status. So we can go with kubectl get all. So yeah, now you can see it's container creating. Okay, so soon it will be available. Just wait for a couple of minutes. So I'm just waiting. You can see the cluster IP, the backend, the DB, and the front end, and this is the default one, right? So you can see backend is in running condition, right? So just wait for a couple of seconds or minute. Let it be all three pod up and running condition, then we'll just move to the second step, which is check the default communication between all these three pods. Still creating. kubectl get ports -o void w. Yeah, it is in running condition. You can see that 1 2 3 is in running. Okay, let me go with kubectl get all. Yeah, this is okay. Now you can see all are in running condition, right? Now move to the next step, which is check default communication between these ports. To check the communication from so we are going to check the communication from front end port to the backend port using curl command, and we are calling the backend services with the port number 80. So for that one, we will use kubectl exec command, execute command, right? So let's move to the front end port using the command kubectl exec hyphen interactive terminal front end hyphen hyphen bash. Now I'm in the front end port. Let's try to hit on the backend port using curl command. So command is curl backend port number 80. Yep, here you can see welcome to Nginx. So you can see the welcome page of Nginx server. So it's accessible. Now let's try to call the database port from the same front-end port, and we will verify the database port with the port number 3306 is accessible from front-end port using telnet utility. So we need to install the telnet using the first of all the command line tool like apt-get command. So I'll go with apt update, let it be update this entire system. Then I want to go with apt install telnet utility. Okay, let it be go. So it's updating and then it will install the telnet. Done. Now it's successfully installed. Let's call the DB service from front end port using the command line tool telnet. Telnet DB 3306. Yeah, here you can say it is connected and it's asking for the password, right? So front end port is able to connect to the database. That's the default behavior of communication in Kubernetes. Communicate with everyone, right? So I'll exit from here, and it is not acceptable. Am I right? It is not good that every port can communicate with each other without having any kind of policies. In the same manner, if we check from the backend port, it will also accessible a database port. Let's check it from the backend one more time. So I'll go with the front end. Let me replace backend backend. Okay. Now the same command apt update. Then I will go apt install telnet -y, and then we will check for the DB also, right? Yep, telnet DB3306. Yeah, see, it's connected. Am I right? So let me exit from here. So here you can see currently both front end and back end port can access my database port, which is not good. For the security purpose, front end port should not communicate to the database port. Am I right? So here network policy come in the picture. Network policy can be used to prevent the communication. So let's allow the communication only to the backend port using the network policy, not from the front end port. So for the network policy, we can get the code from official documentation and modify it as per or your need. So this is the thing, we can copy it from here and you can modify it as per your need. So let me go with my code, which I have already copied and modify as per my need. So this is I have write down. Let me copy and then I will explain. So I'm back. VIAM network policy policy.yaml. Okay, I'll save it. Now let me explain. So here you can see kind is network policy. Okay, with the name DB netpool. In the port selector field, we define MySQL port, this one, and we are going to create the policy for incoming traffic to the database port. All the incoming traffic on database port should be blocked except the train traffic coming from which one? Backend port, right? That the reason in the port selector field we define the backend role here, right? So eventually only backend port will be able to communicate with the database. So here two things is very important: port selector, this one port selector, and policy type. So pod selector select the particular pod in the namespace as the network policy, which schedule be allowed as ingress source or egress destination. And policy type, it may include either egress or ingress or both. The policy type field indicates whether or not the given policy applies to the ingress traffic to selected port and egress traffic from selected ports or both. And if you talk about the YAML, inside the YAML file, spec.pod selector, this one, spec.pod selector, this defines the pod on which we are going to apply the policy. In this case, it is MySQL database pod, right? And spec.ingress.from, this section defines the only pod from which ingress traffic should be accepted. So that's the reason I allow my backend pod. And last, spec.ingress.port section define only the port which on which ingress traffic should be acceptable. So here it is 3306. So in short, all incoming traffic to the database pod should be acceptable only if coming to the port 3306 and only from backend pod, right? So let's apply and see what happened. So I'll save and quit. I'll go with the kubectl apply -f command one more time. I press enter, sorry. Network policy does not exist. Kubectl apply -f network policy.eml, sorry. Yeah, now you can see here, you can see policies applied to the MySQL pod, and it's ready for me, right? So let's get it view and describe the policy. So we can go with kubectl get network policy. So you can see the policy db netpool is ready for me. And if I go with the describe, let's go with the describe, describe. The policy name is db hyphen netpool. Yeah, here it is. So you can see policies apply to MySQL pod and allow only incoming traffic from backend port 3306, right? Now time to the final check. So this time backend port is still able to connect to the database port using the telnet utility, but not from front end port, right? So let's check it from the backend first. Hopefully should be able to communicate. So if I go with the backend and if I go with the kubectl telnet db, yeah, it is connected. You can see it's connected. Cool. Let me exit from here. And if I go with the front end, should not work. Front end telnet db, see, it's trying. Cool. So here you can see the front end port cannot connect to the database port, and the access is restricted. So this is how we have restricted the traffic and improved the security at some level using the network policy in Kubernetes cluster. So guys, that's all about this demo. Hopefully you enjoyed and learned new things, and soon I will come up with another new interesting topic. Till then, keep practicing. If you feel something I have missed or you wanted to know more something else, please reach out through my social media links, which is mentioned in the description. And if you like this video, please do not forget to like, share and subscribe my channel and press the bell icon button for the latest update. Thanks for watching. Stay safe and goodbye.